Welcome to our lesson on linear equations in two variables. In this particular lesson, we're looking at solving simultaneous equations by the substitution method. Now, we already know that substitution means to replace, or to exchange one component with another. So there are about 3 steps that we're going to follow in order for us to be able to solve simultaneous equations using the substitution method. The first step is that you look at the 2 equations carefully and then choose a convenient variable which you need to make the subject of the formula in that particular equation. So you either pick equation 1 or equation 2, and then in that particular equation choose one of the 2 variables, make it the subject. That creates an expression of one variable in terms of the other. Once that is done, then you now get that expression and substitute it in the remaining equation so that you create one equation that now only has one variable. You create an equation in one variable. So with the equation in one variable, you are able to solve it and find the value of that variable. Once you have solved the equation in one variable and you have found the value representing that particular variable, you can go back and substitute that value in one of the expressions that you have, or one of the 3 equations, principal equations, and then you replace that value so that you solve for the remaining variable. So these are the simple steps that we follow when solving simultaneous equations using the substitution method. So we're going to look at an example so that I can explain further on these steps. So there is an example here which says solve the simultaneous equations 2x minus y equals 5 and 5x plus y equals 16. Okay, so once again, our example is 2x minus y equals 5, then 5x plus y equals 16. Okay, so with this, we're going to call this our equation 1. And we'll call this our equation 2. So from our steps which we have gone through, we have said that we are going to look at one of the 2 equations. Either we look at equation 1 or we look at equation 2, whichever that you pick. So for example, if we pick equation 1, equation 1 is 2x minus y equals 5. So we have got equation 1 here. Now in equation 1, we need to decide to make one of the variables the subject. So for example, we can make x the subject or we can make y the subject. Now when changing the subject of the formula, we know that we can make any of the variables given in an equation the subject. But of course, we are also mindful of the convenience that comes with the variables that have got coefficients. So if you have a variable with a smaller coefficient, it will be convenient to adopt that variable. In this case, we can say the variable y has a coefficient of -1. So it will be easier or more convenient, involving less calculations, to make y the subject as opposed to x the subject, which has a coefficient of more than 1, which is 2. Because for us to cancel the coefficient, we will require to divide by that coefficient or to multiply by its reciprocal. So if we are dividing by 2, the calculation will not be as simple as when we are dividing by 1. So in this case, we can say in equation 1, which is 2x minus y is equal to 5, we can change the subject of the formula to y, which we can do by moving y to the right of the equation and moving 5 to the left of the equation. You already know that that is the principle we call the additive inverse. Okay, by the additive inverse we are able to transfer. Okay, if you remember the additive inverse, you are able to transfer a term from one side of the equal sign to the other. So when we rearrange these two terms, the 5 is positive on the right side of the equal sign, so by additive inverse it will appear on the left hand side as negative 5. In the same way, the negative y on the left hand side of the equal sign will appear as positive y on the right hand side. So this statement means that y is the subject of the formula. So in effect, we have created equation number 3, in which we have made one of the variables the subject, or we have expressed one variable in terms of the other. So our next step, we have said that we now get this expression that we have generated and substitute it in the remaining equation. So since equation 3 was derived from equation 1, equation 3 was derived from equation 1, therefore we are going to substitute the expression of equation 3 in equation 2, which means we'll write 5x plus y equals 16. This is our equation 2. So in this equation, we are going to replace or to substitute the value of y, which is as indicated in equation 3, that y is 2x minus 5, which means we will rewrite the equation and say 5x plus, now where there is y, we'll substitute and put 2x minus 5, because this is our y. Then we continue the equation and say equals 16. So we have created an equation in one variable x. Okay, the equation 5x plus 2x minus 5 is equal to 16 is now an equation in one variable x, which we can solve by collecting the like terms. So we have 5x plus 2x these are like terms. Then the negative 5 will appear as positive 5 across the equal sign, giving us on the left hand side 7x and on the right hand side 21. So to find our x, we divide both sides by the coefficient 7, so that we arrive at x is equal to 3. That means we have found the value of x. Then finally, we say that once we found one value, we can now either get equation 1 or equation 2, or equation 3, so that we replace this value of x, we substitute it to find the remaining variable. So for example, if we get equation 3, which says 2x minus 5 is equal to y, it means where there is x, we'll put 3. So say 2 times 3 minus 5 is equal to y. So we know 2 times 3 is 6. 6 minus 5, that will be our y. So in short, y is equal to 1. So that is how we solve simultaneous equations by the substitution method. Again, you can try to check by replacing 3 for x and 1 for y in any of these equations and confirm. For example, in the equation 2x minus y is equal to 5, we know that if x is 3 and y is 1, we'll have 2 times 3, which is 6, minus y, which is 1, which means 6 minus 1 is 5. And that statement is true. It should be true for equation 2 as well.